Hello, I'm Fedor Duzhin, and welcome to the first lecture in ordinary differential equations. So here is the little plan for today. I'm going to record a few chunks according to this outline, and then you can watch them one by one. So we have a textbook, and the good thing about it is that you can download it from NTU-Learn. Also notice that whenever I teach, I always make a big point of connecting my courses to other courses that you have learned. So for instance, in differential equations, there will be a lot of material from calculus to linear algebra, and also you'll need the knowledge of MATLAB programming. Alright, now let me continue with some mathematical examples. Let me give you an analogy from calculus or probability theory, right? So here is, I hope you know, the cumulative distribution of the standard normal distribution. The probably most important point about this integral is that you cannot really solve it, so you cannot integrate it explicitly. But at the same time, it doesn't prevent people from figuring out a lot of properties. So if you need to calculate any particular, well, for every particular x, if you want to calculate phi of, I don't know, 0.7, then you can make it with any precision that you want, and you can figure out the properties of phi of x, for example. Because of the fundamental theorem of calculus, you can find the derivative and then the second derivative, and then you can figure out where phi is increasing, decreasing, concave upwards, concave downwards, and so on. The point being is that although it is impossible to calculate it in the traditional sense of the word, you cannot express it as a function in terms of logarithms or cosine or whatever. But it is still very possible to work with the function phi of x. And moreover, it's probably one of most important functions in all of mathematics, widely used in applications. So let me give you an example from the theory of differential equations. So this example is not real in the sense it's been made up, but I think it's pretty clear, right? So suppose that you have you know that some function satisfies this equation. You know that suppose that y prime and y itself, they are related by this equality. Then you can try to solve it, say using Wolfram alpha, but I hope you will believe me if I'll tell you that it's impossible to solve it. But at the same time, you can clearly see that y prime is positive because the right hand side of this equality is the sum of squares, so it has to be positive. And if y prime is positive, then of course the original function y has to be an increasing function. So although we are not able to solve this differential equation, we still can establish a certain property. Right? So the important point here being that, strictly speaking, this is actually more of a typical case. So it is kind of a luxury when you are able to solve a differential equation explicitly, right? So usually you cannot. So, and the theory of differential equations is mostly about how to work with differential equations that we cannot solve explicitly, right? But at the same time, somehow the subject of differential equations is kind of special in the sense that here the practice of education is usually it is very traditional, it is very old-fashioned, right? So usually in courses of differential equations, students are taught techniques to solve differential equations that are very, very particular. So they can do very, very little classes of differential equations, and these techniques were invented a long time ago. But I think you'll believe me if I tell you that no matter how hard you try, Wolfram alpha is always going to be better at solving differential equations than you. So I think it's time to move on and to abandon teaching a lot of tricks how to solve differential equations in favor of a very beautiful, by the way, and meaningful theory, general theory. Right? So in our class, we will only learn like 4 most important methods to do separable equations, linear first order equations, linear second order with constant terms, and how to do systems of linear differential equations. So the rest will be general theory and mathematical modeling, and there will be a project and so on and so forth.